To do any repair properly, you need the right tools. And one tool no one should be without is a Haynes manual. They have over 200 titles available that contain information that's easy to understand. Haynes manuals contain photos and diagrams of a complete vehicle teardown that will easily help you become a better do-it-yourselfer. It's an easy way to save money and get that feeling of satisfaction that comes with doing the job yourself. Let the crew of professionals at Haynes help you on your next repair. Hi, I'm Bill Stern. Welcome to the Car Care Seminar videotape on carburetor repairs. You know, I try to maintain my own vehicle myself, whether it's everyday maintenance, a specific repair, or just keeping my car clean. I'm a do-it-yourselfer. Why? Because it's satisfying and I save a lot of money. Now, with the complexity of today's vehicles, I do need help. And the folks at Champion Auto Stores give me a lot of help by carrying the right products at the right prices and providing me with the right answers. Like free take-home tech tips available at every Champion Auto Store that cover a variety of subjects. And the Car Care Seminar weekly TV show with the latest in new parts and accessories. Also the library of Car Care Seminar repair tapes covering everything from basic vehicle maintenance to the latest in sophisticated electronics. It's all covered and in easy to understand language using basic hand tools. Tools like this Haynes manual, written for your specific vehicle. Haynes manuals are easy to understand with illustrations and photos showing you everything from vacuum hose routing diagrams to general vehicle maintenance charts. Everything you need to know about your vehicle is in this manual. Now, the basis of this tape is to use the information contained in this manual to repair a carburetor that could possibly cause your car not to start, or drivability problems that could cause poor fuel economy and/or performance problems. This tape will show diagnosing and replacing many of the components on the carburetor in your vehicle. Guiding us will be Scott Cusey, Champion Auto Store's Technical Communications Director. We hope after viewing this tape you'll be more comfortable in tackling this job. Now, let's get started.
When it comes to troubleshooting drivability or starting problems on today's high-tech carbureted vehicles, a lot of people figure that, hey, there's too many hoses or wires, so they don't want to work on them. But with a few of the right tools and our help, you can. That's what Car Care Seminar is all about, saving you money by helping you learn how to perform the repairs on your own vehicle the right way and the safe way, the first time and every time. Hi, I'm Scott Cusey, and I'll be your narrator and host as we take a look at troubleshooting and repairing performance and starting problems commonly experienced with carbureted vehicles. Now, troubleshooting drivability problems used to be pretty easy and straightforward back when I started working on vehicles. Of course, that was when mechanical fuel pumps, non-feedback carburetors like this, and even point-type ignition systems were popular. But today's highly advanced and electronically controlled vehicles pose a new challenge for all of us. But you know, it's not a challenge that we can't overcome. It just seems like the hardest part is either knowing where to get started or where to locate the information that you need to perform the task. As I just mentioned, this videotape will cover identifying and repairing drivability problems normally experienced on carbureted engines, both new and old. During this chapter, I'll briefly discuss the topics that we'll cover and introduce you to the tools that you will need to perform the repairs described. In Chapter 2 will begin our series of chapters that cover drivability or starting problems commonly encountered with carbureted engines, specifically choke pull-off testing and replacement. In Chapter 3, we'll look at inspecting the choke thermostat along with replacing and adjusting the two most common styles. Another carburetor part that can cause loss of power and fuel economy is the power valve circuit. Now, during Chapter 4, we'll look at diagnosing power valve circuit failure and how to repair it. In Chapter 5, we'll look at the carburetor circuit that allows you to take off from a stop sign, specifically the accelerator pump circuit. In the late 70s and early 80s, vehicle manufacturers began a decade of computerized carburetor controls, commonly referred to as feedback carburetors. The reason they were referred to that way is because they used a couple of sensors to feed information back to the onboard computer, and the onboard computer also controlled certain actuators contained in the carburetors. One of the actuators used that was controlled by the onboard computer was the mixture control solenoid. In Chapters 6, 7, and 8, we'll explore testing, replacing, and adjusting mixture control solenoids. During Chapters 9 and 10, Jim Bates will join us to discuss testing and replacing throttle position sensors, which are common both to carbureted and fuel-injected vehicles. The final chapter, in which we'll concentrate solely on carburetors, is Chapter 11, during which we'll completely disassemble a carburetor, rebuild it, and readjust it back to factory specifications. That pretty much wraps up the areas we'll be discussing on this tape, so now let's talk about the tools that we'll be using to perform the testing and replacement portions. Now everybody pretty much realizes you'll need a good selection of basic hand tools to work on your vehicle. Some examples of that include combination wrenches, both metric and standard, a good selection of pliers including locking pliers and needle nose type, 1/4 inch drive and 3/8 drive shallow and deep well socket sets, again both metric and standard, a torque wrench, a hammer, some punches, and a rubber mallet, Phillips and flat blade screwdrivers, one of my favorites, a magnetic screwdriver and a selection of bits, a pair of safety glasses, a set of metric and standard tubing wrenches, some shop towels and hand cleaner for cleaning up afterwards, and a drain pan, some funnels, and a gas can. You'll also need a few basic shop type chemicals, including thread lock adhesive, some carburetor parts cleaning solution, and a spray type carburetor cleaner. Now let's look at some of the more specialized tools you may need. Torx bits are becoming a popular type of fastener for a lot of different items on today's vehicles. So you'll most likely need a set of Torx bits that I suggest you get from size 10 through size 50. For General Motors carbureted vehicles newer than 1980, you'll need some of these special tools for making fine-tuning adjustments either during a carburetor overhaul or even during an engine tune-up. Now another couple of common troubleshooting tools are a hand vacuum pump and a handheld vacuum pressure tester. We'll use those to check vacuum diaphragms and vacuum-related switches and relays. You'll also need a handheld digital volt ohm meter for testing the electrical circuits involved with your carburetor and a tach dwell meter for final carburetor adjustments. A digital multimeter like this one has all of those options built right into it. It's also a good idea to have around some jumper or test leads. And one of the most important items any mechanic has to have is the correct service manual for the particular vehicle they're working on. One of the best you can buy is a Haynes manual, because they deal specifically with the disassembly and reassembly of your particular car. From specifications to detailed instructions and illustrations, you'll find just about everything you need to know about your vehicle in one of these. Well, that pretty much wraps up our tool selection. Now, the topics demonstrated on this tape are typical examples of carburetor repair procedures being performed on common vehicles. For details on the procedures for your particular make, model, and year, once again, a Haynes manual is the way to go. And the best place to pick one up is, of course, Champion Auto Stores, as they carry a complete line of Haynes manuals right in stock. I'd like to thank you for choosing Car Care Seminar and for giving us the opportunity to help you learn more about your carburetor. Before you start your next project, check to see if there's a Car Care Seminar tape to help you do the job the right way, the first time, and every time. Now, let's get started with our first repair.
Whether your vehicle is computerized or not, if it's equipped with a carburetor, there are two important items that must work properly together to help your vehicle start quick and remain running during cold weather conditions. Those two items are the choke thermostat and the choke pull-off or vacuum brake. Let's talk about choke pull-offs. They are located underneath the air cleaner, on the side of the carburetor, and are connected to the choke blade via linkage on one end, and on the other end there will be a vacuum hose attached. Its duty is to slightly open the choke blade on initial engine startup to prevent an over-rich fuel condition. Symptoms of a choke pull-off that has failed include an engine that starts and immediately stalls, rough engine operation right after initial startup, and black smoke from the tailpipe during cold engine operation. On the other hand, a misadjusted choke pull-off, one that opens the choke blade too far after initial startup, would cause engine stalling when cold and a hesitation on acceleration during the engine warm-up period. If you suspect your choke pull-off is not working, the first step is to perform a visual inspection to make sure the vacuum hose is connected and in good condition, and to be sure the linkage between the pull-off and the choke blade are actually connected. If both areas appear all right, then start the engine and watch for movement of the pull-off. No movement indicates a defective pull-off. Another method for testing and adjusting a choke pull-off is to use a handheld vacuum pump. Simply connect the hand vacuum pump to the choke pull-off and apply 20 inches of vacuum. Once again, the pull-off should move and hold vacuum. If the hand vacuum pump does not hold vacuum and the pull-off does not move, replace the pull-off. Some pull-offs have a small bleed hole on the backside that must be covered with a piece of tape or your finger during testing. To replace your choke pull-off, you will need a magnetic screwdriver, a needle nose pliers, and a Haynes manual for your particular vehicle. First, you'll need to remove the air cleaner to access the pull-off. Make sure to mark or note the location of any hose connections that lead to it before disconnecting them. Next, remove the mounting screws from the old pull-off. This is when the magnetic screwdriver comes in handy. Carefully remove the pull-off while disconnecting it from the linkage. Take your time so as not to disturb or bend any linkages during removal. Many choke pull-offs have a bracket that must be transferred to the new part. Remove the pull-off from the bracket if so equipped. When purchasing a new choke pull-off, it is often a good idea to have the serial number from the carburetor or the old one along with you. Compare the old and new pull-off to be sure of correct replacement. If the old pull-off was earlier removed from a bracket, install the new pull-off to the old bracket. Install the new one in reverse order of removal by carefully connecting the linkage and reinstalling the mounting screws. Tighten the mounting screws securely. Lastly, make sure you check the adjustment once it is installed. To do so, connect up a hand vacuum pump, and with light finger pressure on the choke blade, apply vacuum to the choke pull-off. With a drill bit of the appropriate size, measure the opening distance between the choke blade and housing. Generally, there should be between 1/8 and 3/16 of an inch gap. But make sure you check a Haynes manual for the correct specification on your vehicle. If it is not within specifications, reset it by turning the adjustment screw or by putting a slight bend in the linkage. Reinstall the air cleaner and reconnect any hoses removed earlier. Once adjusted, start the engine to be sure of proper operation.
Now let's briefly recap the steps for testing and replacing a choke pull-off. First, remove the air cleaner and inspect the vacuum hose and connecting linkages. If damage or deterioration is found, perform necessary repairs before continuing. Then start the engine or connect a hand vacuum pump and apply 20 inches of vacuum. Watch for movement of the diaphragm. If no movement is noticed, replace it. If you're performing the test with a hand vacuum pump, check for a bleed hole that may have to be covered during the procedure. To replace a choke pull-off, disconnect the vacuum hose and remove the mounting screws. Carefully disconnect the linkage while removing the pull-off from the carburetor. Compare the old and new parts to be sure of proper replacement. In some cases, you may have to change a bracket from the old one to the new one. Position the new pull-off onto the carburetor while carefully reconnecting the linkage to it. Reinstall and tighten the mounting screws and vacuum line. Check and adjust the pull-off as per the instructions detailed in a Haynes manual.
If your vehicle has a carburetor, whether it's computerized or not, it is still equipped with a choke thermostat. Your choke thermostat will most likely resemble one of these and will be located on the side of the carburetor, in which case they are referred to as an integral choke. Or they will be located on the intake or exhaust manifold and connected to the carburetor via linkage, in which case they are referred to as a divorced choke. In either case, your choke thermostat might even have a wire coming from it. This wire is connected to a small heater that sits next to the bimetal spring to assist choke operation once the ignition key is turned on. Choke thermostats can fail in two different manners. The most common manner is when the bimetal spring inside the thermostat becomes weak and will not totally close the choke blade during cold weather. Symptoms of this type of failure include hard starting when cold, or engine stumbles or stalls upon acceleration during the engine warm-up period. The other manner in which a choke thermostat can fail is when it fails to totally open the choke after the engine is fully warm. This can cause sluggish engine performance, poor fuel economy, black smoke out the tailpipe, or even failure to pass a state emissions test. To check your choke thermostat, remove the air cleaner and snap the throttle. If the outside air temperature is less than 50 degrees and the engine has not been run in the last 5 or more hours, the choke blade should snap all the way closed. The other test requires you to run the engine until it is at full operating temperature. This will usually take about 10 minutes or 5 to 8 miles of highway driving. With the engine shut off and the air filter cover removed, check to make sure the choke blade is totally open. If yours is electrically assisted, test to make sure you have power at the electrical connector. With the ignition key in the run position and with the engine cold, disconnect the electrical connector at the thermostat and in its place, connect a voltmeter. Most vehicles require 8 volts or above for proper choke thermostat operation. If voltage is not present at this wire, check for open circuits and repair the electrical wiring before replacing the choke thermostat. The items you may need to replace your choke thermostat include a Phillips or large flat blade screwdriver, a needle nose pliers, a 3/8 drive socket set, and a Haynes manual for your particular vehicle. In most cases, you will have to remove the air cleaner to gain access to the choke thermostat. To replace a divorced choke, first disconnect the linkage rod from the carburetor. Now remove the choke thermostat cover or stove if so equipped, and remove the linkage rod from the thermostat. Remove the mounting screw or bolt and remove the choke thermostat from its mounting position. Compare the new and old thermostats to be sure of proper replacement. Set the new thermostat in position and start the bolt by hand to prevent cross-threading. Tighten the bolt securely once installed. Reattach the linkage rod to the choke thermostat and reinstall the thermostat cover or stove. Reconnect the linkage to the carburetor and reinstall the linkage clip. Move the throttle and check to make sure there isn't any interference or binding of linkages. Reinstall the air cleaner housing and you're done. To replace an integral style choke, once again you will have to remove the air cleaner assembly. Note the routing and attachment points of any hoses connected to the air cleaner. Place a small mark on the graduated scale of the choke housing as to the position of the thermostat you are removing. If so equipped, disconnect the electrical connection from the terminal on the outside of the choke. Remove the small screws that secure the choke thermostat in place. Be careful not to drop or lose the small retaining clips. A magnetic screwdriver comes in handy if they are metal screws and clips. With the screws removed, you can grasp, twist, and remove the thermostat from the carburetor. Once again, compare the new and old thermostat to be sure of correct installation. Position the new choke thermostat on the housing, making sure to engage the tab on the thermostat with the notch in the choke linkage. Once positioned, move the thermostat back and forth several times while watching the choke blade. If correctly installed, the choke blade should move freely along with the movement of the thermostat. Then, reinstall the retaining screws and ring or clips and gently snug them up. Don't fully tighten them at this point. Consult the Haynes manual for the correct adjustment specification on your vehicle. Adjust the line on the thermostat to the correct position on the scale of the choke housing. Once adjusted, fully tighten the retaining screws. Then, reconnect the electrical connector to the thermostat. Reinstall the air cleaner, and start the vehicle to test the choke for proper operation.
Let's recap the steps involved for testing and replacing your choke thermostat. To test your choke thermostat for correct cold operation, the engine must not have been run for about 5 hours and the outside temperature must be less than 50 degrees. Remove the air cleaner cover and snap the throttle. The choke plate should fully close. If not, replace the choke thermostat. The other test requires you to run the engine until it is at full operating temperature. Shut the engine off and once again remove the air cleaner cover. The choke blade at the top of the air horn should be fully open. If your choke thermostat is electrically assisted, check for voltage at the feed wire with the ignition switch in the run position. Most vehicles require 8 volts or above at the wire for this proper operation. If voltage is not present at this wire, repair the electrical circuit before replacing the choke thermostat. To replace your choke thermostat, in most cases you will have to remove the air cleaner. On divorced chokes, remove the choke stove if so equipped, and remove the mounting screw or bolt that attaches the thermostat to the manifold. Then remove the linkage from where it attaches to the carburetor. Compare the new and old units to be sure of the correct replacement. Carefully reconnect the linkage to the carburetor and reinstall any clips that may have been removed. Reposition the new thermostat in place and reinstall the mounting screw. Reposition the choke stove if removed earlier, or reconnect any electrical connections. Move the throttle and check to make sure there aren't any linkages binding. On integrally mounted chokes, note the position of the choke setting on the graduated scale. Disconnect the electrical connection if so equipped. Remove the small screws that secure the thermostat and remove the thermostat from the housing. Compare the new and old thermostats to be sure of correct replacement. Position the new thermostat on the housing, making sure to engage the tab of the thermostatic spring with the notch on the choke linkage. Reinstall the retaining clips and screws and adjust it as per the instructions in a Haynes manual. Once again, operate the throttle to be sure of free movement.
If your vehicle's engine is carbureted, it is equipped with a power valve or power valve circuit that adds fuel to the engine during heavy load conditions. On Rochester, Carter, and other styles of carburetors that utilize a power valve piston or metering rods, failure symptoms would include sluggish engine performance under load, or a lean condition noticed by surging or bucking while driving down the highway. These conditions are commonly attributed to varnish buildup on the power piston inside the carburetor. This causes it to stick in the down position, creating a lean fuel mixture. To cure this problem, you must remove the air horn from the carburetor. Remove the air horn gasket and pop the power piston and metering rods up and out of their position. Be sure not to disturb or lose the small spring that sits below the power valve piston. Clean the outside of the power piston and metering rods with carburetor cleaner to remove varnish. Also, be sure to clean the piston well at the same time. Since partial carb disassembly is required to access this style of power piston and internal varnish deposits have been found, we suggest rebuilding the carburetor at this time. You will also probably damage the air horn gasket, which can only be purchased in a complete carburetor kit. For a complete demonstration of those procedures, view our chapter on carburetor rebuilding. On Ford and Holley carburetors that utilize a diaphragm type of power valve, failure symptoms would include poor fuel economy, sluggish engine performance due to a rich fuel mixture, and even black smoke out the tailpipe. A power valve failure of this type can often be attributed to an engine backfire. This style can be replaced without complete disassembly of the carburetor. On many Holley carburetors, the power valve is located inside the fuel bowl in the main metering block. On Ford vehicles, where carburetor removal is necessary, invert the carb over a funnel and gas can to drain the fuel out of it before disassembly. Then locate and remove the screws retaining the power valve cover. Fuel deposits inside the cover are an indication of a power valve diaphragm rupture. With the cover removed, you can use a large, about 1-inch wrench to loosen and remove the power valve. Compare the new and old power valves to be sure of correct replacement. On Holley Performance carburetors, there will be a small 2- or 3-digit number stamped into the hex of the power valve. Make sure the number on the old one matches the number stamped into the new one. Position the new gasket on the new power valve and start it in the threads by hand to prevent cross-threading. Snug the power valve in place with the wrench, but be careful not to over-tighten it, as it is quite easy to do with a wrench that large. Then reposition the power valve cover and install the cover retaining screws. Snug them up with a screwdriver once all of them have been started in the threads. Reinstall the carburetor on the vehicle and test drive to be sure of correct diagnosis.
Now let's review servicing or replacing the power valve. Servicing your power valve system, if it utilizes a power piston and metering rods, commonly found on Rochester, Carter, and many import applications, requires you to partially disassemble the carburetor. Because damage to some of the gaskets will occur during this procedure that can only be obtained in a carburetor overhaul kit, we suggest rebuilding the carb at this time. With the power piston and metering rods removed, clean any varnish or deposits from them, as well as the piston well inside the carburetor. Once clean, reinstall the power piston and check for free operation. Reassemble the carb in the reverse order of disassembly, making sure to replace any gaskets that may have been damaged. On many Ford and Holley carburetors, a diaphragm type of power valve is used and can be replaced without complete carburetor disassembly. On the Holley type, the float bowl will have to be removed, and on the Ford type, a small cover and 4 retaining screws will have to be removed. Use an appropriate wrench on the hex part of the power valve to remove it. Install the new power valve and gasket, being careful not to over-tighten it with the large wrench. Reinstall the float bowl or cover and tighten the screws appropriately. Start the vehicle and test drive it for proper operation.
The accelerator pump circuit in your carburetor adds an extra shot of fuel each time you step on the gas pedal to bridge the fuel delivery gap between idle and cruising RPMs. The accelerator pump itself is located internally or externally on the carburetor and is operated via linkage connected to the throttle plates. Symptoms of a failing accelerator pump include a hesitation during acceleration from a stop sign after the engine is fully warmed up, a hesitation during acceleration when attempting to enter a freeway or while passing another vehicle, or even an external gas leak near the carburetor. Before condemning the accelerator pump as your problem, make sure the entire ignition system, spark plugs, distributor cap and rotor, and spark plug wires are all in good operating condition, and check the ignition timing to be sure it is adjusted to the correct specification. If the engine is in good tune, you may then consider replacing the accelerator pump. The only tools you will need to replace an externally mounted accelerator pump is a screwdriver or 1/4-inch drive socket set. Externally mounted accelerator pumps are commonly found on Ford and Holley carburetors. To replace this style of accelerator pump, you may or may not have to remove the carburetor from the vehicle. For our demonstration, we chose to have the carburetor already removed. First, if you are going to completely remove the pump cover and the accelerator pump linkage has more than one possible position, mark its location before disconnecting the linkage. Remove the 4 screws retaining the accelerator pump cover to the carburetor and position the cover aside and out of your way. Then, with the aid of a screwdriver, remove the old accelerator pump diaphragm and spring. If it is equipped with a rubber pump check valve, inspect it for damage, as a pump check valve can create similar drivability problems as would a bad pump diaphragm. If check valve damage is noticed, you will have to rebuild the entire carburetor, as that is the only way to purchase this item. If the check valve appears okay, reinstall the new pump and spring. Be sure the pump is positioned in the same direction as the old one was removed from. Reconnect the linkage to the pump cover and start all pump cover screws by hand to avoid cross-threading. Tighten all the mounting screws securely. On Rochester, Carter, and other styles of carburetors with internal accelerator pumps, you must partially disassemble the carburetor to access the pump. During disassembly, you will most likely damage some of the gaskets, so you will need to purchase a carburetor overhaul kit to obtain the accelerator pump cup and gaskets necessary. For a complete demonstration of carburetor removal and rebuilding procedures, review our video chapter on carburetor rebuilding. The actual accelerator pump is a small rubber cup that is mounted onto the accelerator pump shaft. With the spring removed, you can work the rubber cup off from the shaft. Use care when removing the cup from the old shaft, as the plastic lips that hold the cup in position are quite fragile. Reposition the new cup in the same direction as the old one. That's all it takes to replace your accelerator pump.
Now let's review the steps for replacing your accelerator pump. On some Ford and Holley carburetors, the accelerator pump is located on the outside of the float bowl, and disassembly of the carburetor is not necessary. Simply remove the 4 screws retaining the accelerator pump cover and remove the pump and cover from the float bowl. Position the new pump on the cover in the same direction as the old one, position the accelerator pump spring, and reinstall the cover and retaining screws. On Rochester, Carter, and many import carburetors, replacing the accelerator pump will require partial carburetor disassembly. Because damage to some of the gaskets may occur during the process, we suggest obtaining a carburetor kit and replace gaskets as needed. Once the carburetor is partially disassembled, you can remove the accelerator pump and plunger from the pump well. With a small screwdriver, remove the accelerator pump cup from the plunger. Some will have a clip and spring that will have to be removed, while others will be held in place with a round garter spring. Install the new pump cup in the same direction as the old one. Reinstall the accelerator pump in the pump well, and reassemble the carburetor in the reverse order of disassembly.
The mixture control solenoid is an electrical device used on computerized carbureted vehicles that controls fuel flow from the main bowl of the carburetor to the main well, along with controlling an idle air bleed circuit. Symptoms of a failing mixture control solenoid would include a sudden drop in fuel economy or hesitation on acceleration. To test a mixture control solenoid, you will need a small, flat-bladed screwdriver, a hand vacuum pump, a jumper lead, and a digital voltometer. To prevent burns, always start with a cool engine. Label and disconnect any hoses attached to the air cleaner assembly and remove the air cleaner from the engine. The mixture control solenoid will be located inside the carburetor. During our demonstration, we will be working on a General Motors vehicle. The first test is to simply listen for the MC solenoid to cycle. Turn the ignition switch to the run position. On many models, you should begin to hear a clicking sound as the mixture control solenoid cycles. If a clicking noise is heard, the electrical part of the solenoid is okay. If no sound is heard, turn the ignition switch off. Ground the diagnostic terminals of the ALDL connector. For a complete demonstration of grounding the ALDL connector, refer to our onboard computer troubleshooting tape. Once again, turn the ignition switch to the run position. The solenoid should begin cycling. If no clicking is heard from the solenoid, replace it. Next, use a small flat-bladed screwdriver to release the lock tab and disconnect the electrical connector from the solenoid. Connect the leads of your ohm meter to the terminals of the MC solenoid. Polarity is not important. Set the ohm meter to the low ohm scale. You should see a reading between 20 and 50 ohms. If the reading is within specifications, the problem is most likely in the wiring harness or the computer itself. If the reading is not within specifications, replace the MC solenoid. If you have a General Motors vehicle with an externally removable MC solenoid, as shown, there is an additional test that can be performed. With the ignition key off, disconnect the electrical connection from the MC solenoid. Remove the solenoid from the carburetor and inspect the seals for damage. Replace any seals that are swollen or damaged. Reconnect the electrical connector to the solenoid. Connect a hand vacuum pump to the end of the solenoid with a piece of vacuum hose that will fit snugly over the rubber seal or stem. Using a test lead, ground the Kelly green connector. This is the terminal normally used to check MC solenoid dwell. Turn the ignition switch to the run position, but do not start the engine. This will energize the solenoid in the lean position. With the hand vacuum pump, apply 5 inches of vacuum to the solenoid. The vacuum should hold for at least 5 seconds. If it will not hold vacuum, as in our demonstration, replace the solenoid. If it will hold 5 inches of vacuum for 5 seconds, that part of the solenoid is okay. Then, disconnect the ground lead from the Kelly green connector. The vacuum gauge reading should go to 0 instantly. If it does not, replace the solenoid. To test it for restrictions, apply a rapid hand vacuum pump action several times. Wait a couple of seconds in between strokes. The gauge should move slightly, then return to 0 before the next rapid stroke. If the gauge does not return to 0 between these rapid strokes, the fuel feed orifice is restricted and the solenoid should be replaced.
The mixture control solenoid is the electrical equivalent to the power valve circuit on non-feedback carburetors. Let's recap the testing procedures just performed. First, ground the AL-DL connector and turn the ignition key to the run position. Listen for the MC solenoid to begin cycling. If no sound is heard, test the winding resistance of the solenoid with an ohm meter. Set the meter to the low ohm scale, and with the electrical junction disconnected, the resistance between the two terminals of the solenoid should fall between 20 and 50 ohms. If not, replace it. If it is an externally accessible solenoid, you can remove it from the carburetor and visually inspect it for damaged seals. Then, with the wiring connector in place, connect the hose from a hand vacuum pump over the stem of the solenoid. Ground the Kelly green connector and turn the ignition switch to the run position. Apply 5 inches of vacuum to the solenoid and it should hold that vacuum for at least 5 seconds. Then disconnect the ground lead from the Kelly green connector and the vacuum gauge on the hand pump should go immediately to 0. If not, replace the solenoid.
To install an externally mounted solenoid, the tools you will need include a set of screwdrivers and the correct MC solenoid and gasket for your vehicle. To prevent burns, always start repairs on a cool engine. Because gasoline and gas vapor is very flammable, there are some important precautions to remember when working on the fuel system. Always work in a well-ventilated area. Do not smoke while doing fuel system repairs. Keep open flames, sparks, or bare bulbs away from the work area. Do not work in an area with a gas appliance equipped with a pilot light. And have a fire extinguisher of the proper rating close at hand. First, make sure all accessories, including the ignition key, are turned off. Label and remove any hose connections to the air filter housing, and remove the air filter housing from the engine. Now, locate the mixture control solenoid on top of the carburetor. Unplug the 2-wire harness from the solenoid. A small, flat blade screwdriver may be useful to release the locking tabs. Remove the screws attaching the solenoid to the carburetor, and remove the MC solenoid by pulling up with a slight twisting motion. Compare the old solenoid to the new one to ensure proper replacement. If the old gasket is still on the carburetor, remove it, making sure the mounting surface is clean. Then, position the new gasket on the carburetor. Put a small dab of clean engine oil on the rubber O-ring at the bottom of the new MC solenoid. This will allow it to slip into place easier and help prevent damage to the O-ring. Now, carefully install the MC solenoid by pressing down with a slight twisting motion to help the O-ring slip into place. Reinstall the mounting screws and reattach the wire harness. Reinstall the air cleaner assembly and reconnect any hoses or wires earlier removed. Test drive the vehicle for proper operation and you are done.
To replace an externally mounted mixture control solenoid on a GM vehicle, first turn off all the accessories including the ignition key. Remove the air cleaner. Unplug the 2-wire harness from the solenoid. Remove the mounting screws and remove the solenoid from the carburetor by gently pulling up with a slight twisting motion. Compare the new and old solenoids to be sure of correct replacement. Place a dab of clean engine oil on the O-rings of the new solenoid. Now carefully install the new solenoid in the carburetor using downward pressure and a slight twisting motion. Reinstall the mounting screws and tighten to the proper torque specifications. Reattach the wiring harness. Reinstall the air cleaner and reconnect any hoses disconnected earlier. Lastly, test drive the vehicle for correct diagnosis.
To install and adjust an internally mounted mixture control solenoid on a General Motors carburetor, you will need a magnetic screwdriver and assorted bits, a digital volt ohm meter, a carburetor gauge set, a mixture control adjusting tool, an idle mixture adjusting tool, an idle mixture seal plug removal tool, a small pin punch and a ball peen hammer, a 1/8 inch drill bit, a number 8 sheet metal screw, a pair of locking pliers, the appropriate carburetor gasket set, a small tube of thread locking compound, and the correct mixture control solenoid for your application. To prevent burns, always begin repairs on a cool engine. Because gasoline and gas vapors are extremely flammable, there are some important precautions to remember whenever working on any part of the fuel system. Do not work in an area with a gas heater equipped with a pilot light without having adequate ventilation. Even if there isn't a gas heater with a pilot light, still make sure to work in a well-ventilated area. Don't smoke when performing fuel system repairs. Keep open flames, sparks, and unprotected light bulbs away from the immediate work area. And, most importantly, have a fire extinguisher close at hand. Begin by making sure all accessories, including the ignition key, are turned off. Label and remove any hoses or wires attached to the air cleaner housing. Remove the air cleaner from the carburetor. For our demonstration, the carburetor will be off from the engine during the replacement. For complete details on carburetor removal procedures, refer to our video segment on carburetor rebuilding. Remove the upper choke lever from the end of the shaft by removing the retaining screw and rotating the lever. Then remove the choke rod from the lower lever inside the float bowl casting by holding the lever outward and twisting the choke rod counterclockwise. Use a small pin punch to drive the accelerator pump lever pivot pin inward until the lever can be removed from the air horn. Set the lever aside and out of your way. Next, remove the vacuum brake hose from the tube on the float bowl. Remove the air horn attaching screws. And don't forget the 2 countersunk screws inside the throat of the carburetor. A magnetic screwdriver can be used to prevent dropping the screws. Carefully remove the throttle position sensor plunger. Do not lose or misplace this item. After all the attaching screws are removed, lift the air horn straight up and off from the float bowl. On our carburetor, the accelerator pump plunger, MC solenoid plunger, and air horn gasket remained attached to the air horn itself. If the air horn gasket is damaged during the procedure, a new one can be obtained in a carburetor rebuilding kit. Remove the plastic filler block from over the float valve. Carefully lift out each metering rod assembly along with its return spring. Next, using the lean stop adjustment tool, turn the lean stop screw all of the way in while counting the number of turns. Record the number of turns and then remove it from the float bowl. Next, remove the screw retaining the MC solenoid electrical connector. Now you can carefully lift the mixture control solenoid and its connector assembly from the float bowl. Compare the old solenoid to the new one to ensure proper replacement. Carefully set the new solenoid and wire into place. Be sure the bottom of the solenoid sits properly on the large spring in the bottom of the float bowl. Then reinstall the screw that secures the electrical connector on the carburetor. Now, reposition the lean mixture stop. Once again, set it to the same number of turns as it was positioned to earlier. Now reinstall the metering rods and springs. Insert the lean limiting adjustment tool from the gauge kit into the hole next to the metering rod and down to the base of the metering jet. Next, insert and hold the MC solenoid plunger lightly down against its stop. Using the mixture control adjusting tool, turn the lean mixture screw counterclockwise until the plunger does not touch the gauge. Then, turn the screw clockwise until the plunger just touches the gauge. Once adjusted, remove the mixture control solenoid plunger. Now you can remove the gauge and reinstall the plastic filler block over the float valve. We suggest always installing a new air horn gasket from a carburetor kit to prevent leaks or future problems. Lift the corner of the gasket and install the accelerator pump. Reinstall the MC solenoid plunger. Now remove the plug from the air horn that covers the lean mixture screw and save the plug. Next, using a 1/8 inch drill bit, drill a hole into the rich mixture screw plug. Insert a number 8 sheet metal screw, and with a screwdriver or pliers, remove the plug from the air horn. Also, remove the cover over the idle air bleed valve on the air horn by drilling out the rivets. With the cover removed, closely examine the top of the valve and note whether or not it has a letter stamped on it. If it does, it will affect the final adjustment procedure. Next, reinstall the air horn on the carburetor and tighten the air horn screws in the proper sequence to prevent warping or leaks. The proper tightening sequence for the carburetor you are working on can be found in a Haynes manual designed for your particular vehicle. Reinstall the throttle position sensor plunger. Now place the idle air float gauge from the adjusting kit into the D-shaped hole in the air horn. With light pressure, push down on the gauge to measure the amount of travel of the solenoid plunger. The correct amount of travel is 4/32 of an inch. If the amount of travel needs to be adjusted, use the tool from the gauge kit that fits the rich stop screw and turn the screw either up or down to achieve the correct amount of travel. When the adjustment is correct, reinstall the plug and use a drop or two of red Loctite to seal the plug back in place. This plug must be reinstalled to maintain the adjustment once back on the engine. Remove the float gauge and place the hook-shaped idle air valve gauge into the D-shaped hole. Position the hooked end of the tool over the top of the idle air bleed valve. Hold the gauge down lightly until the solenoid plunger bottoms against its stop. Adjust the idle air bleed up or down until it just touches the bottom of the hooked end of the gauge. If you earlier found a letter stamped on the idle air bleed, you are done with that adjustment. If there wasn't a letter stamped on it, the final adjustment must be made with the engine running. Refer to a service manual for details of this procedure on your particular vehicle. Continue with reassembly by reconnecting the vacuum brake hose, and reassemble the accelerator pump lever to the pump rod in the same hole as previously used. With a screwdriver, push the pivot rod pin back into place. Next, reattach the choke rod to the lower lever inside the float bowl casting. Once connected on the lower end, reattach the upper end of the rod to the choke blade shaft using the retaining screw earlier removed. Reinstall the carburetor on the engine in the reverse order of removal. With the carburetor reinstalled, reconnect any vacuum lines and electrical connectors earlier removed. Because most final adjustments have to be made without the air cleaner in place, plug any vacuum lines that may still be opened. Connect the positive lead of the digital volt ohm meter to the Kelly green wire connector. It is commonly located near the carburetor or passenger side strut tower. Connect the black lead from the meter to a good engine ground and set the meter to the 6-cylinder tachometer scale. Make sure the transmission is in park, or in the case of a standard transmission, neutral with the parking brake set. After making sure there are no wires or hoses in the way, start the engine and allow it to reach full operating temperature. Make sure you are standing off to the side of the vehicle and not in front of it whenever making adjustments with the engine running. After the engine is fully warmed up and idling, the dwell reading on the meter will begin to vary, indicating that the onboard computer is operating the MC solenoid. On carburetors with no letter stamped on the idle air bleed, the dwell reading should fall between 25 and 35 degrees. Adjust the idle air bleed valve by turning it clockwise or counterclockwise until it is within that range, attempting to be as close to 30 degrees as possible. Perform this step carefully. Only make very slight adjustments, 1/8 of a turn or less at a time, as the idle air bleed is very sensitive. If you cannot get the adjustment close to 30 degrees, and you earlier found a letter stamped on the idle air bleed valve, you will need to adjust the idle mixture screws at the base of the carburetor to bring the dwell reading within range. To do so, you will need to remove the caps that are covering the idle mixture adjustment screws. Follow the instructions detailed in a service manual, or a special plug remover tool can be used to simplify the procedure. With the plugs removed, you can access the idle mixture adjusting screws with a special tool as shown. Bring the mixture control dwell to within factory specifications. If the dwell reads low, adjust the screws out evenly to reach 30 degrees. If the dwell reads high, adjust the screws in evenly to reach 30 degrees. Final fine-tuning may have to be made once again by turning the idle air bleed valve. After all adjustments are complete, seal the idle mixture needle openings with a non-volatile, oxygen sensor-safe silicone sealer. Lastly, reconnect all vacuum hoses, reinstall the air cleaner, and test drive the vehicle for proper operation.
Now let's review the replacement and adjustment procedures on an internally mounted mixture control solenoid on a GM vehicle. Begin with the ignition switch in the off position. To avoid losing any small parts during this procedure, we suggest removing the carburetor from the engine before performing any of the disassembly steps. With the carburetor on the bench, proceed by removing the air horn. If the air horn gasket is damaged during this procedure, a new one can be obtained in a carburetor rebuilding kit. Remove the plastic filler block and carefully remove the metering rods. Using the special mixture control solenoid adjusting tool, turn the lean stop all the way in while counting the number of turns. Record the number of turns, then remove the lean stop from the carburetor. Remove the electrical connector retaining screw and remove the solenoid and connector together as an assembly. Compare the new and old parts to be sure of correct replacement. Position the new solenoid and electrical connector in the carburetor and reinstall the electrical connector retaining screw. Reposition the lean stop by turning it all of the way in and backing it out the same number of turns as was recorded earlier. Reinstall the metering rods and springs. Insert the mixture control solenoid plunger and using the special lean stop limiting gauge, adjust the lean stop as per instructed. Remove the plunger and reinstall the plastic filler block. On the air horn, remove the plug that covers the lean mixture screw and save it. Drill out and remove the rich stop screw plug. Drill out the retaining rivets and remove the plate that covers the idle air bleed valve. Reinstall the air horn on the carburetor. Follow the tightening sequence from a Haynes manual to prevent warping or leaks. Using the idle air float gauge, measure the mixture control solenoid plunger travel. It should be 4/32 of an inch. Adjust the travel by turning the rich stop screw in or out. Reinstall the rich stop plug using red Loctite to secure it in place. Use the shepherd's hook tool to measure and adjust the idle air bleed. Reconnect any vacuum hoses or linkages removed earlier and reinstall the carburetor on the engine. With the carburetor installed,
check and adjust the idle speed and mixture control solenoid dwell with the engine fully warm. Refer to a Haynes manual for the exact procedures on your vehicle.
Okay, Jim, I've got a late model GM vehicle. We'll use that as our example. I'm driving down the road, down the highway as a matter of fact usually, and what happens is I step on the throttle and now I've got a bucking sensation, or it kind of hesitates as I'm going to take off. And I've also got an intermittent check engine light. What do you think?
Well, the fact that you've got a check engine light at all means you're going to have to pull the codes.
Okay, I've done that, and what I've come up with on my particular vehicle is a code 21. Where do we go from there?
Well, first of all, find what the code 21 means. You can refer to the manual that you use to work on the type of car that you have, such as this one.
Okay.
And in the code chart section of this book, we find a list of trouble codes. And code 21 in this case talks about a throttle position sensor problem.
Okay. So what we want to do then at that point in time is a quick 2-minute throttle position sensor test, and we'll show you how to do that right now. What we've got on the bench here is the throttle position sensor out of a carbureted vehicle. And really all a throttle position sensor is sort of like a rheostat, or your volume control knob on your stereo. As you push down on this volume control, it increases the resistance or decreases the resistance depending upon your vehicle, and changes the signal back to the computer. And it's got 3 wires that come out of it just like this. All TPSs have those 3 wires. Now testing it's easy.
It sure is. What we'll use is the ohm meter. And what I like to do is turn my ohm meter onto the 20,000 or the 20K scale, because that's a range that gives you a nice big spread of numbers when you're trying to test something that's going to cause numbers to change all the time.
Okay.
Now, since you have 3 terminals here in your throttle position sensor, and I only have 2 alligator clips, you have to remember which 2 to connect to. So take one lead, either the red or the black, it doesn't matter, and put it in the center of the 3.
Okay.
Then use your other lead to get into either one of the other 2 you want. So let's just do this one. Now we're connected to the center and the bottom terminal, and then we can observe the reading on the ohm meter.
Okay, what I'm going to do is actually press down on this little plunger here, and we're going to watch the reading on the ohm meter go up as I'm pushing down on the plunger. And we want to look for a real smooth transition of those numbers. And this one appears to be okay. You want to do that in both directions. Numbers will go up in one direction, back down in the other, and you want to do it relatively slow, because if you don't do it slowly, you could miss a bad spot in there.
You're right, and the important thing is the numbers should follow what you're doing. Nice and slow progression, up and down or down and up.
Okay, this one appears to be okay. So we've checked our throttle position sensor. That is okay. We've still got our code 21. Now where do we go?
Well, if that's the case, we know that there's something else wrong. So you can get into your manual such as this that talks about trouble codes and diagnostic trees, and we can actually find a diagnostic trees for code 21 and the throttle position sensor. So by following the step-by-step diagnostic tree, we're going to arrive at either a bad wire, a bad electrical connection, or maybe even a bad computer. But it's one of those things that's causing the problem on this vehicle.
Okay. Now, on the other hand, we've got another TPS here that we pulled off of a fuel-injected vehicle. Now, it looks a little bit different, but again, it's got our 3 terminal connectors on that. And why don't we run a test on this one, Jim, and see what we come up with here.
Once again, the ohm meter can be left in the 20,000 range, and take one lead, stick it in the center as you're doing,
okay,
and then you're free to put that one in either of the other 2 you want.
Okay.
And here we have...
Let me see, I got her on there now.
Good. And here we have a reading, so go ahead and operate it just as you did before, and we'll see how this one does.
And we're going up slowly along with my movement, and we'll see. There it is. There's our open circuit, and now look at our resistance is changing again. And we'll come up here, another open circuit.
That's quite erratic, isn't it?
Yeah, it sure is. So that's what's creating my bucking sensation when I'm trying to accelerate, and it's also giving me my check engine light, isn't it?
That's right. This is a bad one, and this is what it looks like. See, the ohm meter is picking up all those bad spots in there.
So hence the reason that you do want to perform this test very slowly, because if you don't perform the test slowly, you go too fast, you could zip right by those numbers and not actually even notice it at all.
Right. Replacing this part would solve your problem.
Sure. 2-minute test, you're down the road again.
Although there are many different styles of throttle position sensors, they can all be tested using the following procedure. Disconnect the electrical connection at the sensor. Set your ohm meter to the 20K scale. Connect one of the ohm meter leads to the center terminal and the other lead to one of the outer terminals. Polarity is not important. Slowly move the vehicle throttle through its entire range of movement. This is called sweeping the sensor. Watch the meter reading as the sensor is being swept. Any glitches noted during throttle movement denotes a failed sensor. This same procedure can be performed by using a digital voltmeter on the 20-volt DC scale and back probing the electrical connector with the ignition switch in the run position. Replacing the throttle position sensor, or TPS, on either carbureted or fuel-injected vehicles can be easy with the right tools and our help. There are several different styles of throttle position sensors in use today, but all will resemble one of the styles shown and will be replaced in a similar manner. The tools needed to replace the throttle position sensor on a fuel-injected vehicle include one or more of the following: a set of screwdrivers, a 1/4-inch drive socket set, a set of small Torx bits, and a 10 megohm input digital volt ohm meter. In addition to those tools, you'll need the following to replace a TPS on a carbureted GM vehicle: a 3/32 drift punch, a hammer, a 5/64 drill bit, an electric drill, a number 8 sheet metal screw, a hex key wrench set, a tube of thread locker, a needle nose pliers, and a TPS adjusting tool. To prevent getting burned and to make the job easier, always begin repairs on a cool engine. The first step whenever working on the electrical system is to turn off all electrical accessories, including the ignition key. The first type of TPS we will replace is on a carbureted GM vehicle. Remove the air cleaner assembly to gain access to the carburetor where the TPS is located. Disconnect the MC solenoid and TPS electrical connectors from the carburetor. Disconnect the upper choke lever from the end of the choke shaft by removing the retaining screw. Remove the lever from the choke rod by rotating it until it disengages from the rod. Remove the choke rod from the lower lever inside the main body casting by holding the lower lever outwards with a small screwdriver and twisting the choke rod. Using a 3/32 drift punch and hammer, drive the accelerator pump lever pivot pin inward until the end of the pin is against the air horn. Lay the pump lever off to the side and out of the way, and using a needle nose pliers, remove the TPS plunger. Using a needle nose pliers, remove the vacuum hose from the choke pull-off. Now, remove the 2 front carburetor mounting bolts with the ratchet wrench and socket. Unscrew the center mounting stud for the air cleaner. Remove the air horn to main body screws. When removing the 2 countersunk screws located inside the air horn, use a magnetic screwdriver to prevent dropping them into the intake manifold. If you are uneasy about removing these screws with the carburetor on the engine, we suggest you stop here and remove the carburetor from the intake manifold before proceeding any farther. Remove the air horn from the main body by lifting it straight up and off. Pushing up from the bottom with a small screwdriver on the electrical connector, remove the TPS assembly from the main body. Using a needle nose pliers, retrieve the spring from the TPS well. Compare the old TPS with the new one to be sure of the correct replacement. Install the new TPS spring. Position the new TPS assembly into the carburetor main body. Be careful to align the groove in the electrical connector with the slot in the main body casting. Push down on the electrical connector and the sensor so the wires and the connector are below the main body casting surface. Reinstall the air horn gasket and air horn, holding down on the pump plunger assembly. To ease installation, insert a thin screwdriver between the air horn gasket and the main body to raise the TPS adjustment lever over the sensor. Loosely install all the air horn screws. Tighten the screws evenly, working from the center outward in a crisscross pattern. Reinstall the two front carburetor mounting bolts and tighten them securely. Reinstall the air cleaner mounting stud and tighten it hand tight. Reconnect the vacuum hose for the choke pull-off. Place the TPS plunger through the hole in the air horn and reposition the accelerator pump lever. Using a needle nose pliers or a small screwdriver between the pivot pin and the air horn, carefully pry the pivot pin back through the pump lever until it is flush with the housing. Using your hand, reinstall the choke rod into the lower choke lever by twisting slightly while holding the lever over with a small screwdriver. Install the upper choke lever back into the choke rod. Position the lever onto the end of the choke shaft, making sure the flats on the shaft align with the flats in the lever, and reinstall the retaining screw. When properly installed, the lever will point to the rear of the carburetor. Plug in the MC solenoid and TPS electrical connectors. The last step is to check the TPS adjustment. This step must be performed with a digital 10 megohm input voltmeter. In the appropriate service manual for your vehicle, or in the instructions included with the new throttle position sensor, locate the voltage specification. Then, back probe the center and lower terminals of the TPS connector as demonstrated. Set your voltmeter on the low voltage scale and connect the leads for your voltmeter to the back probe connectors. With the air conditioning off and the idle speed control plunger retracted, turn the ignition switch to the run position. Read the TPS voltage. Some vehicles, such as ours, will require it to be adjusted with the choke on the high step of the fast idle cam. If it is within specifications, you're done. If not, you must remove a small tamper-resistant plug that covers the TPS adjustment screw. To do so, drill a hole in the plug with a 5/64 drill bit. Be careful so as not to drill too far and damage the TPS adjustment screw. Insert the number 8 sheet metal screw in the hole drilled. Using a pliers, pull on the screw to remove the plug. Use a special TPS adjustment tool to bring the voltage within specifications. On our vehicle, the specification is 0.97 volts on the high step of the fast idle cam. Always make sure your final adjustment is made by turning the screw in a clockwise motion. Once adjusted, place a drop of thread locking compound in the adjustment hole and reinstall the new tamper-resistant plug supplied with the new TPS until it is flush with the boss on the carburetor. Remove your voltmeter and back probe pins and you're done.
To replace a throttle position sensor that is located in the carburetor, begin by turning off all the accessories including the ignition switch. Remove the air cleaner assembly. Disconnect the mixture control solenoid and throttle position sensor electrical leads. Disconnect and remove the choke linkage from the choke shaft. Remove the accelerator pump lever and linkage. Next, remove the throttle position sensor plunger. Remove any vacuum lines connected to the top of the carburetor. Remove the front 2 mounting bolts. Now remove the air cleaner mounting stud. Using a magnetic screwdriver, remove all of the air horn screws. Carefully lift and remove the air horn from the carburetor. Remove the old throttle position sensor and spring from the main body. Install the new throttle position sensor and spring into the carburetor. Install a new air horn gasket and reinstall the air horn. Start all of the air horn screws and tighten by following the tightening sequence found in a Haynes manual. Reinstall and tighten the 2 front mounting bolts. Thread the air cleaner stud back into the carburetor. Reconnect all vacuum hoses. Next, reinstall the throttle position sensor plunger and accelerator pump lever. Reinstall the choke linkage, making sure the choke lever points to the rear of the carburetor. Reconnect the mixture control solenoid and throttle position sensor electrical leads. Lastly, snap the throttle a couple of times and check the setting of the sensor with a digital voltmeter. Refer to a Haynes manual for the specific adjustment procedures for your vehicle.
A carburetor overhaul, or let's refer to it as a tune-up, isn't as difficult as many people think. The tools you will need to perform a typical carburetor tune-up include a 3/8 drive socket set, a set of combination wrenches, a set of screwdrivers, pliers including a standard and needle nose type, the correct size of flare nut wrench, usually 9/16 or 5/8, some masking tape and a marker, and for final adjustments, a hand vacuum pump, a vacuum gauge, and a tacked wall meter. For cleaning, we suggest having a can of aerosol carburetor spray, a bucket of carburetor cleaner to soak the parts in, and a source or air pressure for blowing out clogged passages. In addition to the new carb tune-up kit, we suggest installing a new float assembly, choke pull-off, and choke thermostat. Now is also a good time to install a clean fuel filter, air filter, and PCV valve to ensure maximum performance gains from your work. When purchasing a carb kit, it is often helpful if you have the carburetor identification number or tag number with you. On Rochester carburetors, you can usually find this number on the main body section. On Holley carburetors, the ID number can be found on the air horn or main body section. On most Ford carburetors, it'll be located on a tag, and on Carter carburetors, you can find it on a tag or stamped into the main body section or base plate assembly. The first step is to remove the air cleaner. Tag any vacuum lines or linkages with masking tape and a marker to ensure proper hookup during reassembly. Now's a good time to inspect any fuel lines or vacuum hoses and replace any that are brittle or cracked. Disconnect the fuel line from the carb. If it is a steel line, use the double wrench method, utilizing a flare nut wrench on the line fitting and a backup wrench on the carburetor fitting. Now remove the carburetor mounting bolts. Usually there are 2 or 4 of them, and remove the carburetor from the intake manifold. Remove the carburetor base gasket and clean the carb mounting surface of the manifold. Disassembly should be performed in an orderly fashion. We recommend following the exploded view and parts numbering sheet included with your carb tune-up kit. In our example, we next remove the fuel filter inlet fitting and remove the fuel filter from its cavity. Be sure not to loosen the small spring that positions the filter in its base. Next, we remove the idle stop solenoid, the choke pull-off, and the choke thermostat. Make sure to note the position of the choke thermostat before removing it. Solenoids, dashpots, choke pull-offs, or thermostats should not be immersed in the carburetor solution. Clean these items as necessary with a cloth and spray carburetor cleaner. If so equipped, turn the idle mixture screws all the way in, counting the number of revolutions as you do so. Make note of how many revolutions so you can use that figure as a starting point during reassembly. Next, remove the air horn screws and lightly tap on the air horn to loosen the seal of the gasket. Remove it from the main body. Remove the air horn gasket, but do not discard it at this time, as you will need it to match up to the new one later. Begin soaking parts in carburetor cleaner once removed. In our example, we next remove the choke housing, the power valve or metering rods, and the needle and seat. During disassembly, be careful to note the location of any check balls, such as the accelerator pump check ball shown. Lastly, remove the base plate screws and separate the base plate from the main body. Allow the parts to soak in the carburetor parts cleaner. Generally, about an hour will remove tarnish and foreign materials. Remember, do not soak any electrical, vacuum, or plastic parts in the cleaner. Drain all the parts into your container and blow dry with compressed air. This will not only dry off the parts, but also use the compressed air to blow out small passages to dislodge tarnish and foreign materials. If you don't have compressed air available, a less favorable method is to use an aerosol-type carb spray to clear passages. Because some carburetor tune-up kits come with additional gaskets, make sure to compare the new and old gaskets to assure correct replacement. With all the parts clean and laid out in order on your work surface, you are ready to begin reassembly. Begin by installing a new gasket between the main body and the base and tighten the screws accordingly. Reinstall any check balls that may have been removed earlier. The new needle and seat assembly may appear slightly different than the one removed. Install it as per the instructions with your kit. Next, refer to the instruction sheet provided for the correct float adjustment procedure on your particular carburetor. Holding the new float in place, invert the carburetor and measure the distance between the top of the main body and the top of the float with the float gauge supplied. If the adjustment is incorrect, gently adjust the float tab, reinstall it, and double-check the float level. Do not assume the float adjustment will be correct. Install the float retainer, reposition the metering rods, and install the choke housing. In our example, we also had to install a new accelerator pump seal prior to reinstalling the accelerator pump in the main body. Carefully install the air horn and start all screws by hand to prevent cross-threading. Tighten all the screws evenly once installed. Install the new choke thermostat and adjust it as per the specifications detailed in the instructions. If you removed them during disassembly, reinstall the secondary metering rods. Reinstall the idle mixture screws. Turn them all the way in and then back them out the same number of revolutions as counted when they were originally removed. Reinstall the choke pull-off and tighten the screws securely. Then reinstall the idle stop solenoid and the fuel filter, spring, and fitting. Be sure the open end of the fuel filter faces the fuel line. Position the new base gasket on top of the intake manifold and install the carburetor on top of the gasket. To prevent cross-threading, start the mounting bolts in the threads by hand and tighten them securely. Next, tighten the fuel filter fitting. These usually take a 1-inch wrench, so be careful not to over-tighten it, as damage to the carburetor could result. Using the same 1-inch wrench as a backup, use a flare nut wrench to tighten the fuel line. Sealer does not have to be used on these threads, as fuel lines are flared fittings. Reconnect any vacuum hoses, linkages, or wires leading to the carburetor. If you have installed a new choke pull-off, now is the time to use a hand vacuum pump to apply suction to the pull-off and check the opening adjustment of the choke blade. As mentioned earlier, now is a good time to replace the PCV valve, breather element, and air filter. All that remains is to start the vehicle, check for leaks, and make minor idle mixture and idle speed adjustments. Idle mixture can be adjusted by using a vacuum gauge connected to a manifold vacuum port and adjusting them until you reach the highest mark. Idle speed should be adjusted as per the specifications found in the underhood decal or from a service manual. Once adjusted, install the new breather element and air filter. Position the new air cleaner gasket on the top of the carburetor, install the air cleaner cover, and you're done.
Let's review the 5 easy steps for rebuilding your carburetor. Step 1. Removal and disassembly. First, remove the air cleaner. Tag the locations of all vacuum lines. Inspect the vacuum and fuel lines and replace any that show signs of deterioration. On steel lines, use the double wrench method and disconnect the fuel line from the carburetor. Remember, no smoking during carburetor repairs and work in a well-ventilated area. Disconnect linkages, remove any mounting bolts, and remove the carburetor from the intake manifold. Remove the old carburetor mounting gasket and carefully clean the carburetor mounting surface. disassemble the carburetor in an orderly fashion, laying all parts out on a clean work surface. Follow the exploded view and parts numbering sheet provided with your carburetor kit. Before removing the idle mixture screws from the carburetor base, turn them in until they stop while counting the number of turns, and write down this number. Retain all gaskets to match up with the new ones for correct replacement. Step 2. Cleaning and inspection. Begin soaking all metal parts in a suitable carburetor cleaner solution. Do not, however, soak any electrical, vacuum, or plastic parts in the cleaner solution, as permanent damage will result. When removing the parts, be sure to get all the excess cleaner back into the container and blow out all air passages with compressed air. Remember to wear safety glasses whenever working with compressed air or aerosol sprays. Step 3. Replacement of deteriorated parts. Lay the new parts next to the old ones. Due to technology advancements, the new needle and seat assembly may appear slightly different than your old one. We recommend replacing the float whenever a carburetor rebuild is being performed. Step 4. Reassembly and reinstallation. Reassemble in the reverse order of disassembly or by following the steps backwards on the instruction sheet. Using the float gauge supplied, make sure to check the float level adjustment before installing the air horn or float bowl. Also be sure to compare any old gaskets with the new ones to be sure of correct final operation. Reinstall the idle mixture screws and reset them to the same number of turns as noted during disassembly. For best results during rebuilding, we also suggest replacing the choke thermostat and choke pull-off. Reinstall the carburetor onto the intake manifold, being sure to use a new base gasket. Reconnect all vacuum lines, linkages, and electrical connections disconnected earlier. Reinstall the fuel supply line to the carburetor and tighten using the 2-wrench method if it's a steel line. Replace the fuel filter if not already replaced. Plug any vacuum lines that lead to the air cleaner, as final adjustments will have to be made with the air cleaner removed and the engine running. Step 5. Final adjustment procedures. Start the engine and check for fuel or vacuum leaks. Refer to a Haynes manual for the specific adjustment procedures involved on your particular vehicle. Reinstall the air cleaner with a new air filter and test drive the vehicle for proper operation.
Well, now that you've seen the tape, I hope you've gotten as much information as I have. As we keep learning more about the newer, more sophisticated systems, with the help from the folks at Champion Auto Stores, it becomes much less frightening to repair your own late model car. The tools are pretty much the same as always, but you do need to add a few things to your toolbox from time to time. One thing that's invaluable is the Haynes manual we've been talking about. Not just generic information, but actual photos and repair sequences about your particular model. See, the folks at Haynes actually disassembled the entire car they're writing about, photograph the process, and reassemble it. That way you're obtaining the most specific information available, and there's over 200 different titles available. Visit your local Champion Auto Store to get the right one for your particular car. If you like this tape, keep watching for new Car Care Seminar videotapes to be released. They're all designed to help make you a more successful do-it-yourselfer. Until next time, I'm Bill Stern.